Okay, so today we are discussing about an oblique projectile on an inclined plane. Let us discuss about an oblique projectile on an inclined plane here. Okay, it's a very simple topic. It's a very easy topic. Let us go with that. Now, let us see here. I am considering an oblique projectile. Let us imagine this is an inclined plane. Okay, and this is having an angle alpha is equal to 30 degrees. Let us imagine, and you are throwing a body with certain angle, and this is a parabolic path which is falling here. Let us imagine this is also going to be angle theta, which is equal to 30 degrees here. Okay, so now here this is going to be y-axis, this is going to be an x-axis here. So this is the situation. The parabola is going to fall in this way here. Okay, so this is a parabolic path. Now let us see what is going to happen in a parabola here. It's a very simple and easy topic here. It's a very interesting topic. We shall discuss this in a very easy manner. Okay, so let us see what is going to happen here. So here, if you observe, acceleration due to gravity is acting downwards here. Okay, so now if you observe in this direction, if this is alpha, this is also going to be alpha here. Then this is going to become g cos alpha, and this is going to become g sine alpha here. Okay, so this is g cos alpha and g sine alpha. To understand this in a better way, let us draw the diagram like this here now. Okay, so now let us draw the diagram here. So if you observe this part separately and draw here, okay, so this is x dash and this is going to be y dash. So I have drawn this as an x dash and this as a y dash here. Now you are throwing a parabolic path making certain angle theta here. Okay, if this is theta, now downwards it is not a g here. Downwards acceleration due to gravity which is acting is considered to be g cos alpha. In this direction it is going to be g sine alpha. So to understand better, to compare with the horizontal projectile, I have drawn the upper part which was crossed into a straight horizontal way, so that our imagination becomes easier because we are familiar with the horizontal oblique projectile. Inclined oblique projectile is new for you people. Okay, so for that reason, for comparison, I have drawn this upper part separately and trying to explain it now. So let us see what is going to happen. The first thing you have to find out is time of flight. Now you are going to find out what is a time of flight here in this case. So how are you going to find out the time of flight? Now the basic formula here is ut plus half at square. This is the basic formula here to find out the time of flight. Now this is x dash, this is y dash. This is x and this is y. As this inclined plane is tilted, I have drawn the tilted part separately so that you can understand the concept in an easier and a better way. So this is going to be displacement. So let us take along y dash axis. Now along y dash axis, what are the things you are going to observe? So along the y dash axis, what are the things you are going to observe? You are going to observe s is equal to 0 here. Displacement in the y axis is going to be 0 because the particle starts from the starting point and it is falling on the x-axis again, starting from the x-axis and falling on the x-axis only. So from side, if you observe the parabolic path, you see that it moves upwards, reaches the maximum height and falls down. Okay, moves upwards and falls down. That's it. That means starting point also the same one, the ending point also the same one. If you observe from y-axis, isn't it? Okay, that is going to be observed here. So displacement is going to be 0. Then what is u along this direction? So u is going to become ux dash, which is equal to u cos theta, and uy is going to be u sine theta along the y-axis. Okay, so this is going to be u sine theta along the y-axis. Okay, so So this is u sine theta and this is u cos theta, whatever it may be. Then let us see, this is just like a common thing we are going to observe here. So u will become u cos theta. Okay, so u along the x-axis, that is x dash, becomes u cos theta. U along the y dash is going to become u sine theta here. But I told you that along the y-axis, time of flight means along the y-axis you have to consider. So let us take a u y dash as u sine theta here. You are taking it as u sine theta here. Okay. So now, as the displacement part is going to be 0 here. Next small t, let us imagine to be capital T, because total time to remain in air is called as time of flight. So as a general definition, capital T is the total time of flight taken by a body to remain in air. So I am considering it as capital T here. So I have taken this as a capital T, and along the y-axis, that is y dash axis, according to our problem, our concept, along to y dash axis here, y dash axis, you are going to observe that acceleration is going to become downwards, that is g cos alpha, that is going to be g cos alpha here. So acceleration is acting downwards, that is considered to be g cos alpha here. Then the same things if you substitute here, what are you going to get now? So s means you'll. Then what about the remaining factors here? This is going to be t. So instead of small t, you are going to consider here capital T. Then plus half a. Oh, what is a here? A means g cos alpha. Then what about the remaining factors here? So what about the remaining? T square means what are you going to consider here? So t square is nothing but capital T whole square here. So let us take this as, okay, so this as positive sign, but as the body is going upwards now, opposite to the gravitational force, you can consider this acceleration as minus, because in the starting point the body is moving up against to the gravitational force. You can consider this as minus, so you can write it as minus here. So therefore 0 is equal to u sine theta into t. If you observe this negative sign, it comes to left side, it is going to become plus g cos alpha into t square. You can write like this. So from this equation you can cancel out t and t square here. Then what are you going to get now? So t, you will keep it like that only. This 2 goes to right side. This will become 2u sine theta. This will become 2u sine theta, and this g cos theta comes to denominator. So you are going to write this as a g cos alpha. You are going to write this as a g cos alpha. So finally got a formula for time of flight. It is same as the horizontal oblique projectile, but in horizontal oblique projectile you are going to consider 2 sine theta by g. Okay, 2u sine theta by g, but the difference here is it was downward, so you have taken g, but it was cross. Your vertical component along the x dash y dash axis is not g, that is g cos theta. That is the difference, that's it. Remaining things are same. It's a very simple to understand. So this is for horizontal oblique projectile. This is for inclined oblique projectile. That is the difference. Remaining factors are going to be same. Okay. So let us see what is going to happen now. How are you going to find out the maximum height now? How are you going to find out the maximum height now? Next, if you want to find out the maximum height, it is very simple. Let me draw this diagram once again. This is x dash and this is y dash. This inclined plane diagram, I am making it straight so that our visualization becomes easier now. And this is going to be the maximum height here. You need to find out what is the h maximum in this case. Okay, so what is acting downwards here? What is acting downwards? You know downwards the component is g cos alpha here. G cos alpha is acting downwards. So which formula are you going to consider here? You may consider v square minus u square is equal to 2as. This is the basic formula. I'm going to write here. So now, if you are going to consider Vy dash square minus Uy dash whole square is equal to 2ay dash into s. Okay. So here you need to consider s to be h maximum. Okay. And what are the remaining things you have to change here? So at this place, Vy dash is going to be 0. At the highest point, Vy dash is going to be 0. Okay. Because when you go along the y-axis, the body, if you observe from this side, at the highest point, Vy component is going to become 0 as you are strong in basics. No need to explain about all these things now. So Vy dash is going to become 0. Then this part is going to become 0. And Uy dash whole square. What is Uy dash whole square? This is going to become U square sine square theta. Okay, is equal to 2. What is ay dash here? Okay, so here this is ay dash. And what is this ay dash? It is going to become minus g cos alpha here. So minus g cos alpha, g cos alpha into s. Okay, so what is this s? S is going to become h maximum here. Okay, so this minus and this minus are going to be cancelled here. These are going to be cancelled. Then what is the final formula you're getting? Let us see. So from this you'll understand that h maximum is going to become u square sine square theta by 2g cos alpha. U square sine square theta by 2g cos alpha. Okay, so this is the final formula going to get. But what was the formula in the horizontal projectile case? It was u square sine square theta by g, 2g. Okay, this was the formula here. But as it is a oblique projectile, this formula has been changed. Instead of g, now the component acting along gx dash is going to be 2g cos alpha. G cos alpha is an extra thing. Cos alpha is coming into the scene here. So this is the formula we're going to get. Okay. So if you have understood this, then let us go for the case of a range. Okay. So we shall discuss about a range now. Now I am considering this as a parabola, and downward component is g cos alpha, and this is going to be range. This is going to be range. This component is going to be range here. Okay. So how are you going to find out the range here? Let us consider what is acting in this direction. This is a g sine alpha is acting in this direction. Okay. So as you are considering this one, you can consider this as minus a g sine alpha here. Okay. So minus g sine alpha. So this is ax is equal to minus g sine alpha. So you all know that range is considered along the x dash axis. Time of flight is considered along the y-axis. Maximum height also considered along the y-axis. But what about the range? Range should be considered along the x-axis. Okay. So how are you going to find out the range along the x-axis? So if you are going to consider the range, the formula is the same one. S is equal to ut plus half at square. So what are the changes you are going to do here? S should be considered as r. U should be considered as ux dash, which is considered to be u cos theta, because this is theta according to this concept here. So in this direction it is u cos theta. Okay, so in this direction it is going to be u sine theta. Okay, so I am considering ux dash as u cos theta here. Then what are the remaining things you need to consider? Acceleration in this case is left side. So you need to consider this as a g sine theta here. Okay, g sine alpha. Okay, so this is considered to be g sine alpha here. Acceleration is minus g sine alpha in this case. Okay, so now what is t here? T is going to become time of flight. T is the next point which we need to understand here, which we need to explain here, is range. So how are you going to find out the range here? It's very simple. I am taking this part which is inclined plane in this way here now, in a straight line, so that you can imagine in a very clear way this inclined projectile is drawn here separately for better understanding and for easier understanding here. Your imagination becomes very easy now. So if you observe here, instead of this G is g cos alpha. In this direction, acceleration along the x-axis minus g sin alpha. So the same formula you're applying, s is equal to ut plus half at square. So displacement in this case is going to become range. U is going to become ux dash, that is going to be u cos theta here. And acceleration in this case, because range is considered along the x-axis, time of flight is considered along the y-axis, okay, and height is also considered along the y-axis. But what about this? What about the range? Range is definitely considered along the x-axis. So how are you going to solve this? So very simple. Okay, so the basic formula is this one, but u is ux dash, that is u cos theta. A is equal to minus g sin alpha. Okay, A is considered to be minus g sin alpha. Then t, small t is capital T, which was time of flight, which we have derived already. So the same formula is going to write. Now, if you substitute all these things here, what are you going to get? Let us see. What are you going to get? Let us see here. So displacement, in the place of s, you are going to write r here. Okay. Then what are you going to get now? U is ux dash, which is considered as u cos theta here. So u cos theta into t. So instead of t, you are going to write all these things. That is 2u sin theta by g cos alpha, you are going to write here. Then plus, you'll write like that only. But you know, acceleration along the x-axis is considered to be minus g sin alpha. So you can write here minus half, you'll write like that only. And instead of a, you'll write minus g sin alpha, isn't it? So that's it. Then after that, what is t? T is nothing but capital T, which is 2u sin theta by g cos alpha. That's it. So how you are going to write 4 here, or you can write 2 square u square sin square theta by g square cos square alpha here. That's it. These are the things you need to write here now. So what are the things you need to common out here? So range. What you can common out on these two terms is very simple. Can you common out u square? Yes, you can common out. Here also u square, there also u square. Here you can cancel out this one. So you can consider this 2 also here. So 2 here also present, there also present. I can common out this 2 also. Then in the numerator still, what are the things you can common out here? Sin theta you can common out here, isn't it? Sin theta you can common out there. But in the case of denominator, only g cos alpha you can common, because it is present here as well as there. So if you complete this in the form of brackets, what are the things left here? You are going to see that here cos theta is left. Cos theta is left. Minus sin theta if you common out. What is left here? Here you can you common out this here g square gets cancelled. Okay, so what is left here? Sin alpha is left here, and what is left on the right side is sin theta. This is going to be sin theta, and in the denominator, if one cos alpha is removed, one cos alpha is common, then only one cos alpha is left here. Okay, so this is going to be range now. 2u square sin theta by g cos alpha. Then this cos alpha goes here. So what is this going to become? Cos theta cos alpha minus sin theta sin alpha. This cos alpha you can take here common outside, or you can write one more step, doesn't matter, you can write one more step here. So for clarity you can write one more step. So 2u square sin theta divided by g into cos alpha, and cos alpha is going to become cos square alpha. And what is this? Cos A cos B minus sin A sin B is nothing but, that is going to become cos A plus B. So cos A cos B minus sin A sin B. It is a trigonometric formula. So that is going to become cos A plus B. So I am writing cos A plus B here. So the formula is completed. So R is going to become 2u square sin theta cos theta plus alpha divided by g cos square alpha. Okay, so this is the final formula for range. So this is the final formula for range. You can solve the problems very easily once you know only the terms. Let us take one small example. Here, if you are going to consider the initial velocity as 2 meters per second. Okay, so initial velocity as 2 meters per second. And what else? You can consider, you already considered theta as 30 degrees alpha is also 30 degrees. Okay, so if you consider G as 10 meters per second square, then that's it. This is the data required here. You can solve any problem if he has given angles here. Angles also given. Theta is equal to 30 degrees, alpha is also going to be 30 degrees. But if this is the data, can't you find out the values of maximum height, time of flight? Yes, you can find out. So time of flight here, it becomes 2 into 2 Sin theta is sin 30 divided by g cos alpha, that is g cos 30. That's it. Simply substituting the data, finding the answer after getting calculation. Can't you find out maximum height? Definitely you can find out maximum height because the data is required. Required data is given here. That's it. Okay. So what is the formula for maximum height here? It is u square sin square theta by 2g cos alpha. That's it. This is the formula for maximum height. Can't you substitute here? 2 square sin square 30 by g cos 30 here. This is going to be g cos 30. And you know by the value of g. G can be taken as 10. Just simplifying here. That's it. Cos 30. You know the value. That's it. So you can find out the range also. What do you need to do? Instead of u, you will write 2 square. That's it. Sin 30. And this is sin cos 30 plus 30 becomes cos 60. And this is going to be cos alpha. Cos alpha is 30 here according to the problem taken. So if angles are known, initial velocity is known, g is given as 10 meters per second square. What is the mistake? What is the tough thing here? Just substituting the values and getting the answer. That's it. That's it. You may get this type of examples. That's it. If you observe, there is one problem in mains also. On 10th April, second shift, exam conducted in second shift, 10th April, second shift, you have got this type of problem in 2019, latest. You can go and see. But there, the question was like this. This was, alpha was given as 30 degrees, theta is given as 15 degrees. Okay. So you should know the value of sin 15 and cos 15, that's it. If you know the value of sin 15 and cos 15, you can do it. It's a very simple thing. Nothing is difficult here. Once you know the basic concept, you can understand anything here. Okay. So, my request is, if you understood this, then put one like. You're not going to lose any amount. But I'm gaining abundance of confidence because of your likes. Anyhow, I'm providing all these things free of cost. And you can provide free of cost for me one like and one subscription. You can do it. It's very simple. It will help me a lot to grow my channel. Okay. Thank you very much.